Lesson 9.5 deals with the bell curve. The bell curve is simply a very special mound-shaped frequency distribution, and it's called the normal distribution, and it's used a lot in different statistical things. So it actually has an equation. So if you wanted to graph this bell curve, it's this equation here, which kind of interesting looking, but this is the graph, and we see that it's mound-shaped. And what we have here is we have our mean is 0, so we go to our z-scores that we studied a little bit ago, and then each standard deviation is just 1 because it's a z-score. And what we have here, all of our data lies within this bell curve. And so half our data is to the right of the mean and half our data is to the left of the mean. And we're going to use this to help us find where different percentages of data lie. So going back to the empirical rule, remember that 68% of the values lie within one standard deviation. Therefore, 34% are between 0 and 1. So we're going to be talking about different parts of this and looking at different z-scores. So we use this bell curve to look at different z-scores. So 68% lie within one standard deviation, so from -1 to 1, which means we can split that and say 34% lie between 0 and 1, just to get a better understanding of this curve. So we can have, there's a table, which we'll look at here in a second, of the z-scores or normal distribution table. Shows the z-score value with their percentages. So we often talk about percentages. Go back to standardized test is a big one where we talk about percentages and where you might lie compared to the rest of the people that take it. So here is that table of normal curves area. The first column here gives you your ones and tens values, tenths, and then over here gives you the hundredths. And so if I were looking for 1.27 standard deviations, I could come down to 1.2 and find over to 0.07, and that would be 0.398, which is 39.8%. So that's the intersection of the given row and column, gives the percent of score that fall within that standard deviation. And that's actually between 0 and 1. So find the percentage of the values in the interval 0 is less than or equal to z, which is less than or equal to 1.63. So we want to go to our table, and we're going to find 1.6, 1.603. So we have 0.4484, 0.4484. Oh, wrong one. We want to locate their intersection, which was that 0.4484, which is 44.84%. So the percentage that lie between 0 and 1.63 standard deviations above the mean is 0.44, or 44%. Next one, find the percentage of values lying within 0.6 standard deviations of the mean. So we're going to do the same thing. Actually, what we'll do first is we'll just make a quick sketch. It doesn't have to be anything nice. I know this is on a computer, but you just make a quick sketch of the bell curve, and we're going to locate, it says within 0.6 standard deviations. So here's 0.6 to the right or above the mean, and 0.6 standard deviations below the mean. So we want in this area. So what we need to do is we need to find the percentage for 0.6. And so let's go to our table and do that. So our percentage for 0.6, here's 0.6 standard deviations, which is 0.2257, 0.2257. But then what we need to do is we need to double it, because that 0.2257, or the 22.57%, gives me this half, so we're going to have to double it to give us both parts there. So we get 45.14%. Next one, find the percentage of values such that z is greater than 0.98. So we want greater than 0.98. So let's go ahead and draw a quick sketch again. Just draw the bell curve. 0.98 is right near 1, and we want things above this. So we want this section here. So you could shade that in, say I want that section there. Well, we know that from here over, from the mean to the right, is half of our data. So what we're going to want to do is we're going to take 0.5 and subtract, or 50%, and subtract this part in here, and that will give us this remaining part here. So let's go ahead and find this on our table, 0.98. So we have here's 0.9, and we want to go all the way over to 0.98, so 0.3365. 0.3365, or 33 point, I might have typed that wrong, or said it wrong. So what we want to do is we want to subtract, because that will give us this part in here. That gives us this part in here. Well, we don't want that part, so we want to take that number and subtract it from a half to find this section over here. So we get 16.35%. Percentile rank, this is another thing that we see in standardized tests. The percentage of values less than or equal to a given value. So this, let's say you take some standardized tests and it says you're in the 72 percentile. That means you scored better than 72% of all the people who took that test. And so what you want to do, well, here it talks about 73%. So did at least as well as 73% of all students taking the test. So what that means is when you have your mound shapes data, let's see if I can sketch this really quick. That was not a good sketch. Let's come back over here. Mound shape data, here's our mean, here's 0, so 73% might be over here, and that's better than all these people, so we want to include like whatever standard deviation we're at here. So we know 50% of the people are here, which 73 minus 50, 23% are over here. So we'll have to use this idea when dealing with percentile rank. So find the percentile rank of a student whose quiz score is 29 in a class with a mean of 27 and a standard deviation of 4. Well, first we would want to change that to a z-score. So we don't necessarily need to change it to a z-score, but it would be helpful. Let's see what goes on here. Here we have 27 is the mean. Someone up here was 29. So we know they're better than half because half of it's over here, standard deviation of 4. So what we do here is we're going to find the z-score. So we remember these are z-score, the mean is 0, and the standard deviation is 1. So we know z is our value, 29, minus the mean divided by the standard deviation, which gives us a 0.5. So this person's z-score is 0.5, and so now we can go to our table. We can find 0.5, which is right here. So 19.15%. So here's our 50%, 0.5, all over in this region, plus the 0.1915, the 19.5, we add those together, we get 69.15%. So the 50% over to the left of the mean plus the 19% over here gives us the 69%. Find the interval of z-scores around the mean that contained 44% of the scores. So, well, let's start off by making a sketch. Here's our bell curve. We want 44%. So really, around the mean, 44%. So we want to split this in half and put 22% on this side and 22% on this side. And so what we can do is we can go to our table. And in this case, we're looking up the percent. So we're not looking up the z-score, we're looking up the percentage. So let's come here to our table. We're looking for 0.22. So here's 0.2190, and then here's 0.2224. This one is only, this one is closer to 22%. So let's go with this, and this is 0.58. So 0.58 is our z-score. Find the interval of z-score. So we would be from negative 0.58 to positive 0.58. So that was going back to the table that we're closer here. And so we look at 0.58 and we give the interval from negative 0.58 to 5.8. And that's how we use the bell curve along with the z-scores.